In this video, we're going to look at 8.2, which is solving exponential equations. And this video is going to be looking at two different parts. Part 1 is when we deal with bases that are integers, and part 2 is when we deal with bases that are fractions. So to start, one of the most important ideas in mathematics is to be able to look at a number and see all the different characteristics of it. And one of these characteristics is being able to write it as a base to a power. So for example, 8. If I look at 8, I know 8 is equal to 2 to the third power. 2 times 2 times 2 is 8. So when I see the number 8, I think of a base, which is 2. And if I raise that to the third power, I'm going to get it. So we're going to be breaking down numbers into bases to a power. If I look at, for example, 27. 27, I know 3 times 3 times 3, so 3 cubed is 27. And I can keep going on it. 16, well, right off the bat, I know 16 is a perfect square, so I know it's equal to 4 squared. But I also can look at it and go, well, 4 is also a number I can break down. 4 is 2 squared. So that means that 16 can be written as 2 to a power. And if I look at it, 2 times 2 is 4, and then times 2 is 8, times 2 is 16, so 2 to the 4th is 16. So I can break down a number into different bases on it. 64, I got a lot of equal signs here, so let's see, 64, that's a perfect square, so that's 8 squared. Now I know 8 can be broken down. 8 is 2 times 2 times 2. So 8 can be broken down into 2, which means 64 can be broken down into 2. And if I look at it and I keep going, I'm going to say 2 to the 6th power is 64. And the one in the middle is 64 is also not only a perfect square, it is also a perfect cube. 4 cubed is 64. And so I break down numbers into all of their different bases. 81 is a perfect square of 9 squared. And I know 9 can be broken into 3 as a base. 3 squared is 9. So 3 times 3 times 3 times 3 is 81. So 3 to the 4th. It's this idea of being able to recognize numbers and the bases that they can be changed into with powers on it. So let's try and work our way up. Set 1, set 2, set 3. We kind of go easy into more difficult. Is if you're dealing with an exponential equation, which if you look at it means you have a base, and we can look at some terminology. You have a base and you have a power. If your bases are equal to each other. So if I look at it, 8 and 8. If the bases are equal and your equation says that they're equal, then that means the exponents themselves must be equal to each other. So 3x minus 9 equals 2x plus 4. So if the bases are equal to each other, we can ignore the bases and just set the exponents equal. And then just solve. So I would subtract the 2x, and I would add the 9, x equals 13. So this is the most basic setup, is if the bases are the same, then if the equation says they're equal, the exponents have to be equal to each other. So if the bases are the same, then I can ignore the bases and just set up the equation with the exponents. So 7x minus 3 equals 3x minus 9. Subtract the 3x. Add the 3. And then when I divide -6/4, but always simplify your fractions, and you get -3 halves. Now I say this is the most basic setup, but here's the interesting part. This is our goal. Every single time we solve exponential equations, and we want to create the same base, because look how easy it is. And that's the key to going into set 2. There are times where you're going to have to change one of the bases. And what you want to do is, if you look at it, these don't match anymore. 64 and 8, not the same base. So I can't just go boom, boom, and solve the exponential equations. I have to stop and think about it first. So my job is to do this. My job is to create same bases. So I have to look at this. Now, when I look at this, what the interesting part is 64, 8. I know 64 is a power of 8. So I'm going to change 64, and instead of writing it as 64, I'm going to write it as 8 squared. Now, what's important about this is I did not change the value. Those two are equal to each other. I didn't change the equation. I just changed the way it looked on it. I manipulated it. And so now I have 8 squared is 64. I still have my exponent, that 4x minus 7. And I'm going to keep this right side. And now take a look at this. We have the same bases now. We created the same bases. So I can do the same thing I did up in set 1 where, you know what, I'm going to cross them out. And I'm going to deal with my equation with just the exponents. Because if the bases are equal, then the exponents are equal for the equation. So I'm going to distribute the 2. I'm going to subtract the 8x, add the 2, and then solve x equals -4. So that's your job. Your job when they're not the same is to make them the same. And that's why this part up here, the key concepts, is really important. You're going to have to start recognizing certain numbers for it. So when you go through, you try and make them equal to each other because, man, set 1 was so simple. So if I can turn everything into this, that's going to make my life easier. So can I change this problem, 81 to the 5x minus 4 equals 3 to the 2x plus 20 into the same base? Well, if you look at it, 81 and 3. Well, we did this up above. 81 can be written as a power of 3. 3 to the 4th power is 81. They're the same. I'm not changing the equation. I'm not changing the value of it. I'm manipulating the equation. So we can create the same bases. So it's still saying 81, but I'm writing it as 3 to the 4th. So 3 to the 4th, the power of 5x minus 4 still stays there, equals 3 to the 2x plus 20. Now, it's the same as above. I have the same exact base. So the equation, if the bases are equal, I can cross them out and realize that means the exponents are equal to each other. So I'm going to distribute the 4, 20x minus 16 equals 2x plus 20. Let's do this in one step. I would subtract the 2x, and I would add the 16. So x equals 2. Done. So that's our job. We, for the most part, change the bigger number into the smaller one when we're dealing with changing to one base. It makes it easier because you're not really changing the value. You're rewriting it to create the same base. So I guess it looks like this is still the most important concept. It's the easiest one to deal with, so our job is to make these look like that. I wonder if that's the same with set 3, where we're changing both bases. So in this case, I have to change both, because if I look at it, and how do I know if I have to change both? Well, look at the problem. 27, I mean, can that be written as 9 to a power? Well, 9 to the first is 9, 9 squared is 81. 27 can't be written as 9 to a power, so I can't just change one of them. I have to change both. Now, the trick to changing both is I like to look at the smaller number first, 9. Because the smaller number is not going to have a lot of bases with powers attached to it. So 9, I know the only way to rewrite 9 is to rewrite it as 3 squared. There's no tricks to it. It's just one way to rewrite 9. That's keeping the equation the exact same. So now that tells me, is there a way to rewrite 27 with 3? So look at the smaller number first, because it's easier to break that one apart. And 27 is 3 cubed. So now I'm changing both sides, but even then I'm changing them to the same base. Why? Because then you can just cross out. And so if I take a look, I'm going to cross out the 3's. And I am left with 3 times 3x minus 1 equals 2 times 2x plus 11. I'm just going to solve that equation. So 9x minus 3 equals 4x plus 22. Again, I'm just going to do this in one step. I'm going to subtract the 4x. I'll show it to help. And then I'm going to add that 3 to the other side. And that's going to give me 25 equals 5x. So x equals 5. So even when you have to change both bases, you're still trying to get to that first idea of creating the same base, because that's the easiest way to solve exponential equations. The trick is to always, if you can't rewrite it with what's given and you have to change both, look at the smaller number first. So I always check, okay, well, hey, 32. Let's see, 4. Can that be written as 4 to a power? Well, 4 squared is 16, so no. 4 cubed is 64, so no. I can't keep that base. I have to change both. And so I'm going to look at 4, because that's the easiest one to break apart first. 4, well, there's only one way to rewrite that. 2 squared. So let's keep this other exponent, 3x plus 1. Notice I'm putting them in the parentheses. When that tells me, well, maybe there's a way. Maybe there's a way to change 32 to a power of 2. And that way I would be able to cross out the bases, solve the equation, easy. So if I look at it, 32 is 2 to the 5th power. So there is a way to do it. So now I can cross out the bases, because they're the same, and just deal with the equation with the exponents. So I would distribute the 2, subtract, and then divide. 3/6 is 1/2. And so we're done. So even when you have two bases to change, your goal is always to create the same base. Let's do one last one with this idea is, what if it's 64 and 16? Well, 16, if I look at it, 16 squared is 256, so that's not going to work. But maybe I can change 16. Maybe I can rewrite 16 into a smaller number to a power. And I know 16 is a perfect square, so let's just try 4. So I have 4 squared. I'm going to keep that 3x plus 6. I'm going to put it in a parentheses. And that means maybe there's a way to write 64 as 4 to a power. Because if I could just cross out the 4's, deal with the exponential equation. So 64 is 4 cubed. So look at that, it is possible. And I'm going to skip a step here. So because notice we always set the exponents equal to each other. I'm just going to distribute at this point. I'm going to distribute the 2. And I'm going to distribute the 3. And then I'm going to solve it in one step. I'm going to subtract the 6x, because that's going to give me a 3x over here. I'm going to add the 24. And that's going to give me a 36 over here. So x equals 12. Done. So this is the part 1 of if you have integer bases. And notice, the easiest problem is your goal every single time. Create the same base so you can cross it out. Now part 2 is, what if you have fraction bases on this? And that's not too different for solving. The idea is you still want to create the same base. We just have to remember what it means when you have fractions. So to kind of start us off, we're just going to look at 1/2. We're going to look at the base on all of these. So I'll get purple. If I have a 2 in the base, 1/2 is written as 2 to the negative 1st power. You still want to follow the idea of you need a base to a power. And rather than dealing with a fraction, instead of saying 1/2 to the 1st, I'm going to say 2 to the negative 1st on it. I'm going to create a number there. I'm going to create an integer there. So 1/3, I'm going to look at the base of 3 for this one. So it's 3 to the negative first. 1/4 is 4 to the negative first. So when we're taking a look at this, our idea is to still work with 2 to the power, 3 to the power, 4 to the power, still work with this idea of base to a power. It's just when you have a fraction and you have that larger number in the bottom, we can use negative exponents to change it to exponential form. So 16, well, I'm going to do this one off to the side here. It looks like we have a lot of spaces we can write. Well, 16 is the same as saying 1 over 4 squared. Well, 1 over 4 squared, if I follow this same pattern as up above, I'll use green for this one, that's going to be equal to 4 to the negative second. If I have 1 over, and let's see, that's 2 to the 4th as well, that's going to be equal to 2 to the negative 4th. So that's what a negative exponent means. Negative exponent means take that denominator and you're going to bring it up with a negative exponent on it. So if I have 81, I know 81 is 1 over 9 squared. 81 is 9 squared, but instead of writing it as 1 over 9 squared, I'm going to write it as 9 to the negative second. We also saw 81 is 3 to the 4th, so 1 over 81 is 1 over 3 to the 4th. Well, 3 to the 4th in the bottom is going to be 3 to the negative 4th. So I'm still going to convert the same exact way I've done it before. It's just this idea of I need to create common bases on them. So even though this says we're changing one base, it's going to be a little bit weird for it. When I'm looking at this problem, I have a 4 and I have a 2. And I really have a 1/2, but I don't see a 1/2. Notice I said I have a 2. I look down here, I have a 2. But I don't like it written as 1/2. I want to see it written as a base to a power. So I'm going to change this to, and if it's 1/2, that's really 1 over 2 to the 1st. So I'm going to change it to 2 to the negative 1st. And I would have the 2x plus 4 still remaining. And so I'm going to change the 4. And I'm going to change it to 2 squared. And I'm going to leave that x minus 3 here. We have the same base now, so we can cross it out. And I have 2 times x minus 3 equals negative 1 times 2x plus 4. So distribute on both sides. Let's see, I would add the 2x to get rid of it. So that give me a 4x on the left side. To get that by itself, I would add the 6. So 4x equals 2. 2/4 is the same as saying 1/2. So when we're looking at these, the idea is when you have a fraction, you need to know when you have a fraction, you are going to have to work with a negative exponent. You're going to want to rewrite it. And it's not going to be tricky to rewrite. It's not going to be this mathematical huge work process. If I look at this one right here, I see a 25 and I see a 5. And right off the bat, I mean, forget about the fraction. That's nice because I know 25 right away can be written as a 5. It can be written as 5 squared. And so I can see that on the left side. It's not too hard to recognize that. But the problem is, well, what about this right side? I mean, that's got a 1/5. That's a fraction. But the idea is it's not tricky. A fraction just means you're going to have a negative exponent. So I look at the bottom and I have a 1/5, which is really 1 over 5 to the 1st. So this is just going to be 5 to the negative 1st. And I get this x minus 9. So we did still create the same base and cross it out. I'm going to distribute in this step as well for it. So if I take a look, I get 2x plus 12, negative 1x plus 9. So I'm going to add the 1x, which gives me a 3x. To get that by itself, I'm going to subtract the 9. 9 minus 12, negative 3, so x equals negative 1. So even when you have a fraction, you're still trying to create the same thing we did on the front page. You're still trying to create the same bases. Your job is just to not freak out over the fraction, just to realize you're still doing the same thing, except for now it's with a negative exponent rather than a positive exponent. But now it gets a little trickier if you look at these bottom three. Is 81, 27, 1 over 27. You know, I have here 1 over 25, 125, 1 over 8, and 4. And so you go, it's like, well, this one's harder. But I'm telling you, don't worry about the fraction. Just focus on the numbers. Because all the fraction means is, you know what? I'm going to do the same thing, but I'm going to have a negative exponent. That's all it means. So I'm just going to focus on 81 and 27. And just like we did on the front page, I'm going to focus on the smaller one first. I'm going to focus on the 27. I know 27 is the same as saying 3 cubed. Which means 1 over 27 is the same as saying 1 over 3 cubed. Well, there's my negative exponent. My negative exponent, I'm going to have 3 to the negative third power. I'm just going to take that 3 cubed, and it's going to be 3 to the negative third. That's going to tell me fraction. And I'm going to just leave this one here. 81, can I create it as 3 to a power? 81 is 3 to the fourth. Oh, there it is. Same base. Cross it out. And let's distribute in the same step. It seems like we can do that now. So I'm going to distribute negative 3x plus 3. So I subtract the 3. 1 equals negative 3x, divide by negative 3, so negative 1/3 equals x. And we're done. Same idea, you're still going to work with the smaller number first because it's easier to see what can that be broken down into. And you're not going to freak out over the fact that it's a fraction because it still works the same. I mean, if I look at this, I have a 25 here. I have a 1 over 25, but I see it as 25. And I have a 125 here. Well, I'm going to work with the smaller one first because it's easier to break this down. 25 is 5 squared. But it's a fraction, which means I'm going to be dealing with a negative exponent on it. So 1 over 25 is the same as saying 1 over 5 squared. So that's my negative exponent. I'm going to have 5 to the negative second on it. And I'm still going to leave this 2x here. Which means, can I write 125 as a power of 5? And I can. It's 5 cubed. And so I'm going to keep that x minus 7 here. I now have same basis, so I'm going to cross them out. And I'm going to distribute in this, so I get negative 4x equals 3x minus 21. So I would subtract the 3x, negative 7x equals negative 21, x equals 3. Done. So I'm still doing the same thing. I'm not getting stuck with the fact that it's a fraction. I'm just realizing I'm going to take the power that I'm creating and make it negative for it. So the last one, 1 over 8 and a 4. Not going to get hung up with that 1 over 8. I'm just going to focus on it as an 8. And I have a 4 right here. Now, if I look at the smaller one, it's 4. So let's change that one first. 4 can be rewritten as 2 squared. Same value, just rewriting it, manipulating it, and boom, leave this 5x plus 3. Good. So the question is, can I rewrite 1 over 8 as 2 to a power? Well, let's see. 8 is the same as saying 2 cubed. So it does work if it was an integer, but it's not an integer, it's a fraction. It's 1 over 8. So that means it's 1 over 2 cubed. Well, that's my negative exponent. Instead of dealing with 2 cubed, it's 2 to the negative third. And I'm going to leave this 2x minus 4 here. I have the same base, so I can cross them out. Negative 3 times 2x minus 4 equals 2 times 5x plus 3. I could have distributed, I'm going to do it here. Negative 6x plus 12 equals 10x plus 6. I would add the 6x, which would give me 16x over here. To get that by itself, I would subtract the 6. So 16x equals 6. Always simplify your fractions when I do the division. So x equals 3/8. So it does look like our common theme goes back to the first set of problems we did, which is you want to have a common base. So then I can cross them out. And the goal is always to find what numbers it goes into on it. Sometimes you have to change 1, sometimes you have to change 2. If you have to change 2, always change the smaller one first. It's easier to kind of come up with possibilities if you do that. And if you have a fraction, just realize it's the same thing as the front page, except for you're dealing with a negative exponent. You're still breaking them down. 2 cubed, but I'm going to make that a negative 3. 5 squared, I'm going to make that a negative 2. And that's how you solve exponential equations. I hope this video helps. If you have any questions, just ask.